Thank you guys. Really nice to see all of you. Please grab your coffee and come in. We will talk a little bit interesting. Think about how to manage protocol. And just a few topics what I really want to tell with you today. So my primary things is based only on real experience because we launched Gearbox protocol from the hackathon to 125 millions of TVL. So it was really a lot of mistakes, a lot of things we have learned from practical experience. And I will talk to you how to launch, manage, and update safely DeFi protocol with 125 millions on board. Now it's quite less. We have around 10K lines of code. We use different tokens as collateral. You can just imagine we have 70 at the moment, and this quantity is growing. We have at least 7 major DeFi protocols connected. So users use funds which was provided to the pools with external protocols. And our protocol is DAO-driven from the day zero. It was a quite nice idea to give people leverage. We use credit accounts. Credit accounts are isolated smart contracts. So even before launch the protocol, we ask people to pay some ETH to deploy these credit accounts, these smart contracts, and give them tokens. And we had a really extremely high quantity of participants. It was 5,000 participants at the launch, and they are active contributors to the DAO. And now we are delivering the third version of the protocol. So we have different protocols, we have a lot of system interconnections, and everything is changed on DeFi and could be hacked. So what I'm willing to tell you today, how to sleep well when everything could be is on the fire. And just to explain what Gearbox is. Gearbox is a decentralized brokerage account. And the idea here is that if you want to get leverage, you open your credit account, you provide your part of the funds, and you can take a margin loan from the pool, and then all these funds on account could be managed by you, so you can build any strategy what you want. You can swap tokens on Uniswap, you can provide them into Lido, you can put them into convex position, so it's a full composability. And at the same time, only things that is forbidden, you can't withdraw money into your pocket. So all funds on this credit account, which is isolated smart contract, are used as collateral. And here just a short architecture part. So as you can see, there are two sides. One side is called passive lenders. These people who want to get high yields, they just give capital to the protocol. And another part, we call this nidias, people who are risk takers. They provide initial funds to the credit account, and it's significant. Each credit account is isolated smart contract. Then this credit account immediately takes a margin loan from the pool, and then nidias could send different transactions. And these transactions, the same like you send to normal protocols. So you can swap on Uniswap, on SushiSwap, you provide this money into Curve or Convex and so on. And what we did, at the end of this batch of transaction, we make a collateral check to understand if this credit account healthy or not. And of course, we have some risk management, but it's not what I'm willing to talk today, because this Gearbox, like a lending protocol, has a lot of risk, and today we built a pretty complex system. So on this slide, you can see what under the hood. We have protocol itself, which could be a target for potential attacks of hackers and people who want to steal money. We have our own smart contract system, which is called Router, and we had to develop it. We could not use 1inch, for example, to find all ways between normal tokens and LP tokens. For example, we can find the best route from USDC into complex convex position and build what we called multi-call. So it will be a list of transactions, how to swap and deposit all tokens to get this position. And it also could have bugs, which as a result could block some liquidations. We have liquidators, and of course, each time when these liquidators are under attack, it could be a problem. We have front-end, DEXs, farms, so a lot of moving parts. And to control this from the small team, we have maybe some conversation, and we try to build the process to do that. So we call this system is a gearbox risk framework. And the goal of this system is to provide a full transparency for our community, so each DAO contributor could understand what's going on. We are fully transparent. We talk freely about risk and potential problems. We want to be safe, and we want to deploy with confidence without any side effects. And sometimes it's quite difficult to test that liquidators could get stuck somewhere. So there are 3 steps how we do that. The first one, we write the list of all potential risks and start building monitoring system. For example, as you can see, for the protocol risk, we monitor all changes in the pools. We check that there is no unhandled liquidation. Or if they happened, we get immediately some notification to the Telegram, and I will later check the website. We have a pretty interesting idea. We called it optimistic liquidations. When we work with our credit account, which holds a few different assets, on this example you can see on the right there is LIDO token and CVX Frax3 CRV. To swap it back to VES, we should do a lot of steps. So here you can find we should swap convex position into Frax CRV, then we should unwrap it into 3 CRV, then we should unwrap 3 CRV into DAI, unwrap LIDO to DAI, and then convert them into VES. So it's a quite complex things, and if one pool in the middle could have a lack of liquidity, if we have bug in a router or liquidator, it could be a bad debt as a result. So to really reduce the risk, each 3 hours we have a special robot which run a fork node. We impersonate our configurator to change params, and then we start to liquidate all accounts one by one. And we have a logs that if this account should be liquidated, our system could do that properly, and there is no problem like lack of liquidity or any other stuff related to our software. Another good point which was already into consideration related to front end. As you know, it was a hack to the curve when someone was bribed and changed DNS for some provider, and people use like a malicious front end. Another big problem here is that the industry is growing so fast, so it's quite difficult to check all libraries you use for front-end application. And if someone make a malicious part of the code and you build your new decentralized application, some disaster like unexpected approvals happens. So what we did to eliminate such a risk, we run a special robot. Each few hours, it run a test framework and try as a user to run application and do different stuff like depositing money or building position from our website. And we used our proxy provider, which has like an expected results, which transaction should be built. And if we can find that our software builds the usual user routine, but transaction which was generated by our application is different or malicious, we should immediately send an alert. And of course, we can talk to people that something is going wrong. At least on Twitter, Discord, we can block our application and so on. But on this stage, we check that nobody could add any address for approval and so on. So it also another part how to protect the whole supply chain from the protocol to end user. And of course, maybe one of the nightmares for all of us is a market risk, because as you know, many hacks depends when people could manipulate some assets. Many hacks were happened when it was like a read reentrancy for some curve pools and so on. We have some interesting ideas implemented on this smart contracts, but to monitor more. We have a lot of different robots which run this simulation. For example, we work with RiskDAO. As you can see, it checks the liquidity of the pools. It's quite crucial. If there is no liquidity and we have a big exposure of the protocol of some particular asset, it means, in the case of big price drop, liquidators would start to swap it back and back. We will use whole liquidity and acquire bad debt. So to prevent such things, we continuously monitor all this stuff, got notification to make a better decision. And of course, governance risk. It's another huge topic. Now we have a DAO which votes for some for snapshot, and then multi-sig signs this transaction. And of course, as you know, there were some cases when using social engineering, people try to push some incorrect or malicious transactions. It could be some incorrect way which could be also to the hack. So we built a lot of bots and connected them to the one website which is available for everyone. So if you can compare with centralized exchanges which just provide a paper, we have such things on our accounts, it works totally different. We are fully transparent as a protocol for people who are willing to use, and we try to write this way in more simple way. And we send this data to Telegram notifications and to website. Then the next part is the simulation, how to do next step. So when you get hacked, I have a personal experience when Bug Bounty found some critical bug, and at this point you can't think. You really try to solve something ASAP because you feel you are not okay. And in this case, we discuss all possible actions, what we do. So team could be under pressure. Response time is a king, so be ready for that. And here we're connecting the dots. So we have a continuous monitoring. We have and analyzing all these possible cases together as a team and write all specification what to do. And the last part is how to act, how to respond for all this stuff, and how to continuously deliver a new version, not to break another part. And here, as you can see, how we deliver all changes to our protocol. As you can see, the first part is snapshot voting. So people try to list new tokens, people want to add new protocols, people want to change something. And each changes could break in changes. It could break something and really could have bad consequences. So we use time lock, of course, it's a good practice for 2 days. So if you are not willing to continue to work with these parameters, you can withdraw your money, you can close your credit account, or if you are a DAO contributor, you can tell us, hey guys, there is a mistake, it's a problem, could be here, and so on. And another part, what we implemented for some emergency cases, for example, lack of liquidity, some protocol got hacked, chaining price oracle providing correct data. What really was when Luna price dropped down and we really acted immediately, otherwise the protocol could be hacked because deviation between chaining price oracle and real price was in times. So we have controller, we have lower time to act, and we also have we should not ask a community, we also have a special roles who can manage and solve the problem. And about the protocol updates, when we really create some new transaction, we make this system which everyone could go to Gearbox Risk Framework website, and I'll show the demo, and check what's going on. From my point of view, when we build a decentralized system, it's a very, very crucial. You can find a bad example with multi-chain. When one person controls everything, he was caught by police and the protocol drops. In Gearbox, true decentralization is a key. And another interesting part before showing the demo is CI/CD. It's a practice which is commonly used on GitHub when you deliver your code. In Gearbox, when the queue transaction for multi-sig is provided, we immediately launch a special code on GitHub. We impersonate multi-sig. We apply all this transaction, run all tests, optimistic liquidation I already mentioned, to understand could this change break something existing or not. And of course, we have a system which compare some code from GitHub, which were audited. We have, I think, 7 or 8 audits at the moment to code which were deployed to the Etherscan. And now let's check how it works. So it's a public website. And here you can see what I already mentioned. There are a few things what we are checking. So for example, for optimistic liquidation, you can see the list of all accounts. You can see we have 2 different liquidators to be able to liquidate at any case. If one gets stuck, another should work because they have a totally different code base. You have a list of accounts. You can find all these ways. You can click on any account and get immediately the whole data, history about things. So if we can find some problems for liquidation, we can go deeper and understand everything. Another interesting part, what I already told you, related to protocol updates. And here you can see with the time lock, we have 2 types of transaction. One is queue, which sets the things, and we can immediately understand what's going on. And another is execute. And I think maybe this is interesting. Yeah, so here you can see we have at least things which based on, usually it's a snapshot voting. We have a simulation, what I already mentioned on GitHub. We run a special CI/CD script to check that everything works as expected. And with these changes, we do not break anything. And you can see this comparison tool. So basically, this tool gets the code from Etherscan, then it search for all our GitHub, try to find the same commit and GitHub repo, and then all commits are related to some security audit. So you can simply find that this credit configurator was audited by Chase Security because this commit hash was related to this thing. So you as external part, if you want to understand about the safety of this action, you can find related audit. Sometimes the system detects 2 of them or more. And another part, what I already want to show you, and it's, yeah, and as of course, there is a lot of different data here. Yeah, here. As you can see, it also shows us all differences, previous values. So if you want to learn more, you can click on the actions and find the full explanation in human language. So basically, it's what I really want to present. Thanks so much. If you have any questions, feel free to ask.
Yeah, guys, we have 1 minute. Yeah, thank you. And we have 1 or 2 minutes for your questions. So please raise your hand. Any questions? Yeah, over there.
Hi, Mikhail. Very inspiration talk. I do have one question. Given that you said like every protocol, DeFi protocol, you will have rigorous audit or smart contract coding. So how would you plan to scale Gearbox as the prime brokerage?
Thanks.
What is the best strategy to do that?
It's a really great question. Thanks for that. So we try, on the first part, we really take blue chips protocol to be enabled, like Curve and so on, which is really proven by Battlefield. Now we have the 3rd version, we have a quota, so we able to limit exposure of any protocol. So we can start with a small limit, a few millions, check that everything is going wrong, and if the protocol works well, if it's battle tested, we can continuously increase this limit for exposure of any particular token to create more trust. And of course, it's not by our team, it's more related to our community, DAO members, and risk team. Any question?
Okay, thank you for the great talk. And I just checked the site that you shared, that risk.gearbox, the foundation. Then I just found that there is a minus 50% deviation on the Oracle prices for the
It's
pools.
It's what. Thanks for checking. It's what we listed today. It's not in use, and the problem is in spot price calculation. So we double checked, but for some complex token, as you can see, this is OHM Frax BP. So itself, to compute it correctly, you should do a lot of steps. So on the real market, I think it's more related to incorrect spot price provided by 1inch, what we use at the moment, not to the real time. But these tokens are not in use, and the biggest way why we build it, and thanks for question, that community people like you could check what's going on, ask questions, and we do all steps continuously to make everything safe. Thanks so much.